Hi everybody, this is Rob from Veracity, continuing our video tutorial series. Last time we were talking about custom dashboards, and we looked around at sort of the custom bar chart and the custom pie chart and just using the pre-built widgets and how to configure them. And I mentioned that we would save the really deep topic for another time. Well, that time is today. We're going to talk about custom aggregation queries. So this will be a lot of fun. What I'm going to be doing here is exercising kind of a custom widget type that allows you to directly use the MongoDB aggregation pipeline language to process the data, and then showing you how to sort of marry that data up to a graph, and that that graph becomes a widget that drops onto a custom dashboard. So let me show you where the documentation lives, because I'm going to be going through a lot of stuff here, and you're probably going to want to see it. So let me see if I can pull that up. The custom dashboards article has a section here, which is the custom aggregations on a dashboard. And this is a pretty deep topic, so there's a bunch of information in here for you to follow. I'm going to pull one of these tabs off to the side so that I can reference it, and I'll show you what this means. So let me just pull this over here. So I have my little cheat sheet, and we'll go back to our dashboards. So to start, let's just get a custom dashboard. You see this one has a lot of stuff in it. I'll get a new one. Let's go ahead and just give it a title, so I don't get sort of out of sorts. Aggregation demo. Now I'm going to go back to edit it. So you might remember from last time that you can add custom widgets. We did each of these. So, all of these are sort of configurable with their own sets of parameters. We're going to skip straight down to the most in-depth, in-detail widget type possible, and that is the custom aggregation pipeline. You'll see that this one gives you a little prompt to set it up. There's no defaults that do anything, so you have to kind of give us the inputs. The widget takes just 2 inputs, but that makes it kind of seem like this is simpler than it is. Each of these inputs is a kind of a query in a language. The top one is the data processing pipeline, and the bottom one is the configuration of the graph library to render the outputs. Let's start with something simple. Aggregation pipelines are always arrays of objects, where the objects are sort of processing instructions. So this is valid so far. What I'm going to do is I'm going to have this thing compute a very, 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 very simple, let's do a pie chart, right? So I should also mention to you, if you're looking for language reference for all of this, right, all the stuff I'm typing, you're going to want to look in our documentation. Somewhere in here, you'll find a link to the Mongo aggregation pipeline. If you search, there's lots and lots of documentation in the MongoDB manual. We have a couple of restrictions that are sort of in addition to the restrictions that are in here, and I'll explain those maybe a little bit later. But let's start with a very, very simple example. We're going to say that, okay, first and foremost, I want a pie chart. So the object that I put in the graph configuration uses a constructor called the pie chart, and what we're saying here is each pie is identified by the ID field, and the size of the pie is identified by the count field. So let's do something very, very simple. We'll start by taking every statement in the database and counting them, and then having a pie chart with one slice, and that slice is the count of the statements, right? In order to do that, we have to group the statements up. You can imagine we're kind of taking all the different statements in the database full of xAPI statements and sorting them into groups. And in our case, like I just said, we have one group. So the kind of uniqueness metric is called the ID, right? If I wanted to put them into sort of like buckets by the verb, I do statement.verb.id. If I wanted to put them into buckets by actor, I'd do statement.actor.id. Because I want them all to go into the same bucket, I'm going to use one, just the integer number 1. It really has no relationship to what's in the statement at all, right? So every statement has the same value for the number 1. It's the number 1. So they all end up in the same bucket. And because I need some value for the size of the pie, count is sum 1. So this is a little bit different. This is saying, okay, put everything into the same bucket, counting by 1. Let's try this one. Let me save that. Let me flip this over to all time. There we go. Okay. So I do have to flip that over to all time, which is that the time range setting here is important. On lrs.io, you can go and set it here as well, right? But if it's not set in this one, then you have to set it up top, and that's not always been true. So 100% of the statements fall into the bucket where everything has the same bucket, right? Everything is the same bucket because for every statement, the value of 1 is 1. So that's not that interesting, right? Let's do it by verb. So this is going to be much more interesting. Statement dot verb dot ID. So now what we're saying is this identifier here, this is kind of telling us this is a path into the object, right? We're saying group them into buckets. How do I select which bucket? The value of the verb ID. This is going to output a sequence of objects with different counts. Those counts are going to be counting 1 for each statement that got into each bucket. So let's do this one. Hey, look at that, right? That's cool. Now that's responded. That's passed. That's failed. That's commented. That is a very simple kind of frequency chart for verbs. So you'll note that we have a single metric here, right? And that metric is the count. Let's go back and do something more interesting. So you can kind of append multiple metrics to each group, to each bucket. Rather than taking the sum of 1, which kind of counts up for each thing, what if we were to keep sort of the average of the score, right? Let's do this one. This is going to be kind of silly, but let's go ahead and do it. Let's do where score is the average of, now in this case, rather than putting some number in, I mean, if I put some number in, that would mean for every group, take the average of the number 10. And of course, the average of 1,000 tens is 10. The average of 1 10 is 10. The average of 15 tens is 10, right? We don't want to use a hard-coded number. We want to use a number that comes from the statement. So we'll do statement dot result dot score dot scale. This is right out of the specification. Let's see what happens. Actually, I know what's going to happen, and it's not what you think, but let's do it. It'll be fun. Nothing changed. And if you saw that little flash, you'll note that this did recompute, but nothing changed. Anybody want to weigh in? The pie chart is plotting the count, not the score, right? Let's make sure that the pie chart plots the score, not the count. Okay. Look at that. There are a bunch of verbs that have no value, right? Because there isn't a single statement where that verb includes a result score scale, right? But here are scored, progressed, terminated, and suspended. So those all have about the same average score of 0.5. That's because we use a random number generator. So let's go back and review what we've done here, because we're getting to be relatively interesting, right? We are kind of grouping up by the verb and plotting on a pie chart the average score. So let's say that we wanted to remove the bars over here for, they have 0, right? There's nothing in them. There's a couple of different ways we could do this, but I think what we're going to do is do a pre-filter on the statements. Now, in the MongoDB aggregation pipeline, what's really happening is the documents, in our case, the statements, are sort of flowing through a chain of stages where each stage modifies the incoming values in some way, right? And outputs some number of output values. In the case of group, since it's the first stage, all the inputs are the statements. The outputs are the groups. We can add a kind of a filtering criteria to remove some statements from the stream before they arrive at the grouping function. It's called a match, and it works exactly as you might expect. So let's say we want to only pass through into the grouping stage statements where the result score scaled kind of exists, right? So let's do this. I'm going to copy that instead of typing it. So what are we matching? We're matching statements where statement result score scaled. Now I could put some number. If I put 0, I would be matching statements where the score scale is exactly 0. I don't want to do exactly 0. I'm going to do greater than 0. So I'll do it like that. Again, let's do greater than or equal to 0. The language here is right out of the MongoDB documentation. You can look up all the different operators I'm using. Let's go ahead and run that one. And we should, I hope if I got it right, we'll see all of these things disappear where there was no, yeah, look at that. So all we did here is we filtered out statements that just didn't have a scored scale before we started grouping things up. So now we don't have any groups with no score. And that gives us a much nicer render. So cool. What else should we do? I mean, there are very obvious things like actor, right? Let's say, exact same thing. Just all I'm going to do is group it up by actor. And just for grins, you don't have to do a bar chart. You do a pie chart. Pie chart. You can do a bar chart too. Let's do a bar chart of the average score of actors. Cool. There it is. Now, hey, you'll notice something here that's fun, right? These identifiers are crazy. Those identifiers are crazy because actor ID uses the inbox or the inbox SHA-1 if they exist. So even if the statement actually included an actor.name, the actor.name is not really the unique identifier. So instead, what you get is the actor inbox. Let's go back here. A little lesson that is kind of relevant is that you don't necessarily have to use the actor ID here, right? So because I use actor ID, and this is a string field in the specification, right? And hey, this entire concept of actor.id is something that we've invented. The spec doesn't ask for an ID, but there is extensive discussion of something called the inverse functional identifier in the specification for an agent. Whenever we encounter an agent, we compute its IFI, right? And then we append that as .id, because otherwise you'd be asking this question like, well, whether the actor inbox or the actor's SHA-1 or the actor's account name, right? There's several different things that are kind of the identifier for the actor, and only one of them is allowed to exist at a time. Well, we take whichever one that is and put it in .id. And then we kind of scrub that out for the API so that we pass all the API tests. But this makes all kinds of analytics processes much, much easier. Well, let me do this. Let me make my bar chart have the names, right? Before I get on to doing that, something that I think is really important to note, right, is you probably want to sort of get a chance to look at what the output of each stage is, right? And we have no good way in this tool for you to say, okay, this isn't making sense. What came out of the match, right? Or what came out of group? You know, I don't know. My next stage needs to sort of process the outputs of the previous stage, but I don't know what they were. I didn't know what the shape of those documents was. So we do have a tool where you can kind of paste this in and get a view of the actual output documents. Let's go look at that before we sort of put them onto some kind of graph. I'm going to copy this. I'm going to go out of full screen for a moment, and then we'll go to Tools. So we go to xAPI Lab, and that lets us pick a key. So that's pre-populated. So once you're in xAPI Lab and you've got the credentials, you can copy the aggregation query and paste it in here. Let's see what kind of comes out of the aggregation query before the graphing library graphs it. I'm going to send the aggregation. Do that again. Did I miss it? Oh. So this is an important distinction. The access key I'm using doesn't have permission to do advanced queries. You'll note that, yeah, the user interface is the user interface. You're already logged in, but this is an API that this tool is hitting, which is why I had to put the basic auth setup down here. So I'm going to go make sure that the key has the permissions. Let me do that by doing this. Whole different topic, entirely separate topic, but let me go to management, access keys. Find this key. You'll see right there it says advanced queries false. I'm going to edit, and I'll make sure that this guy has advanced queries. Test. Okay, there we go. So this is the output. Now this is interesting, right? Just like I told you before, when we plot the ID, right? So the bar chart directly plots what's on here, where score is the height, right? And ID is the name of the bar. I told you that we would sort of explore the idea of changing that to be the name, but that's actually kind of hard to do in the other interface because we can't see the intermediate values. All we see is the rendered graph. Let's do this. I'm going to take the ID off of here. So now we're grouping by the unique actor. Let's send that one, and you'll see ID, right, is the whole actor object. Everything else is the same. But ID is the underscore ID is the unique actor object, not the actor's ID. Something to be very careful of. You probably are aware that in xAPI, if you change one of these values, it's a different person. The account, especially if you're using account, the combination of homepage and name is considered the IFI, right? That's pretty important because you can't just go in there and like change those names. That becomes a different person. But anyway, so this has worked fine. This has stacked up well, and the ID field is kind of this complex object. So we can't use that as the name of the bar, right? I mean, we've got the things we need here, but we just can't sort of tell the bar chart use ID dot name. Instead, we have to do something called a projection to reshape this object a little bit such that name is at the top level of each of these documents in the stream. See how count and score at the top level, but then name is under ID? What we're going to do is a projection. And again, this is straight up MongoDB stuff, so you'll find it in the MongoDB documentation. Project just lets you kind of reshape a document by moving fields around. What I'm going to do is I'm going to say name is name. I'm sorry. Let's back that up. Let's do count is count. That basically is just carrying that value forward directly, right? Score is score. But here's the important one, right? Name is underscore ID dot name. Now, just a little obscurity of the Mongo aggregation pipeline. The underscore ID field is always automatically carried forward. Let me show this to you just so you see what comes out, right? Each document in the field, in the array of documents, has top level count, top level score, top level name, and ID came forward automatically. That automatic carrying forward is not necessarily true for other properties. If I take score out of this, score is just gone, right? Score didn't automatically feed forward from the previous stage. So we do have to make sure to do it. You have to explicitly disable the ID if you don't want it or you don't need it by doing ID 0. Now, in our case, it wouldn't matter. It doesn't do any harm for it to be there. But if we want to strike it, then there we have it. So this is a stream of documents that is perfectly adequate for sort of plotting on a bar chart, right? Let's take out count because we don't need count, right? We wanted to plot score. Name, score. Name, score. Let's take our pipeline and go back over to our aggregation widget and just paste this pipeline. We have one complexity here, which is that you saw in those documents a moment ago, there was no ID anymore. This ID 0 explicitly sort of removed it. And we removed it because it was a complex object that wasn't really useful for the graphing library anyway, right? So we don't want to make bars where the name of the bar is the ID. There is no ID. Instead, we want to use name. Paste name right there. Let's hit OK. And now we have pretty much the same bar chart, but we have the nice display names here rather than the crazy identifier that was the account ID. So that's just the basics of this. I mean, you can do all kinds of very sophisticated data analysis by encoding different algorithms into that pipeline. You'll probably want to go read a lot of documentation on the MongoDB pipeline, and you'll probably want to kind of learn a lot about how to use it to solve problems. But it's a full data processing language. You should be able to execute most algorithms over the data with it. There are a couple of restrictions that our system imposes above and beyond what MongoDB does natively. And that's largely because we have a multi-client architecture, meaning that when you input these queries into our database, there are certain things we don't want you to be able to do. For instance, we absolutely positively don't want you to be able to reset your rate limit, right? Or even kind of cross-reference the rate limit against something. You don't even get to know sort of what those numbers are, right? So if I were to go and edit this aggregation, we do a couple of cool things that will make your life a lot easier. So just strike that. If you want to work with extensions, that can get to be tricky just because the fact that MongoDB keys are not supposed to have dots in them, but the keys to an extension is an IRI, and IRIs frequently have dots in them. Luckily, you don't have to think about that. We kind of fix that for you. So if you wanted to sort of, let's say we wanted to group things up by the value of an extension, right? Like I'm taking the average score over actors, right? But let's say I didn't want to take the average score over actors. I want to take the average score by the value of some extension. Maybe that extension identifies a class or a classroom or some group of people or whatever, right? Maybe it identifies whether they took it on mobile or whether they took it on desktop. You can just do statement.context.extensions and then dot, and then you just type out the URL of the extension. Now I'm getting a bar chart of the average score by device, right? Where I've kind of invented this extension. Let me zoom in again so you can see it. Where I've invented this extension called device type. Now, of course, you have to populate that in your data. But if you did, you could use this mechanism to get a bar chart over those fields. I was just talking to somebody earlier today, actually, where the value of the extensions is an array that is then a complex object. This works just like you would think. Device type sub-0 dot device name, right? So if that was an array of complex objects, I mean, that would work just like you would expect it to. This gets more interesting if you want to say like each statement can have multiple values and I want to count each one. Then you have to use a thing called an unwind. And I will leave that as an exercise to the reader to go learn how to use all that data processing pipeline. But that's it. That's I'm going to dismiss that change. That is a basic introduction to how to use the custom aggregation widget. Right now, the custom aggregation widget is not magic. It mostly exposes the query language of the database and allows you to map it up to a render. You'll also note that I haven't covered at all the how to customize the render. I just use like the totally default bar chart and the totally default pie chart. But there's more that you can do with it. You're going to find all of that in our documentation. I won't go into it, but there are several examples of how you can sort of customize the bar chart, the pie chart, the colors. You can even do crazy stuff like multi-rings. And again, this is its own entire kind of language for building graphs. You can get down into the weeds of that by reading the documentation from AM charts, which is kind of the system we use to draw these graphs. We have a very simple setup like bar chart, pie chart. What that does is it computes the sort of more complex AM charts object for you based on these inputs. But if you wanted to do it yourself, you could put the whole thing in here yourself and customize colors and lines and strokes and all that kind of stuff. So you'll find at the very bottom of our documentation links to the various languages that are necessary for that. The AM charts JSON description of the graph, the Mongo aggregation language that helps you compute these values, and then some specific notes about our implementation of the Mongo language and kind of the things that we restrict or don't restrict. And the little special cases we do, like extensions and stuff like that. So that's the end. That is kind of the bottom of the well on custom data stuff on dashboards, unless you want to start writing Veracity plugins, which is a topic for another day.